Hey everyone, this is Mr. K, and today we're going to go over a particle motion problem. So the first question asks us to find the displacement during the first 5 seconds. So what we're doing is we're essentially taking our y2 and subtracting our y1. In order to find those, we're going to use the t values of 0 because that's where we start, and then we're going to end at 5 seconds. So it's just a matter of substituting those values in. When I substitute a 0 into this equation, I'm just going to have 0, 0, and then 15, so that will be 15. And then for the y value on the 5, I would do 5 to the third power, and then times 4, and then minus 32, and then 5 squared, and then plus 15, and I should get negative 285. And so really what you're finding when you're finding displacement is, since this equation gives us the position, it's saying that we're started at a position of 15, and after 5 seconds we move to a position of negative 285. And so then when I subtract those, so I take my y2 minus my y1, you end up with negative 300. So that's going to be our displacement for the first 5 seconds. And then for the next one, we have to find average velocity. Whenever I see that average, I'm already thinking of slope, which is y2 minus y1 over x2 minus x1. But since we already did the y2 minus y1 for our displacement, that kind of saves us some time. So we're going to take that negative 300, and we're going to divide by our change in x. Well, the change in x is x changed because it went 5 seconds, so since it's the first 5 seconds, we're going to divide by 5, and that's going to give us negative 60 for our average velocity. And again, this all is kind of connected because if displacement is how far we moved, but we moved that far in 5 seconds. If I divide those, because distance divided by time is equal to rate, so that's how or rate is equal to distance divided by time. So that's how I know that that matches what we're doing here. Now for the instantaneous velocity, whenever you see instantaneous, already think of a derivative. So when I do the derivative of my equation there, it's just going to be standard power rules, so it would be 12t squared and then minus 64t. And then we want to substitute in a 5 because we care about what's happening at 5 seconds. So then on my calculator I would do 12 and then 5 squared and then minus 64 times 5. Helps if I actually type that in correctly. There we go. And so I get an instantaneous velocity of negative 20. Just show my work here. And then for the acceleration, acceleration is always going to be the second derivative. So, or the derivative of the derivative. So now I'm doing another, just again, standard power rule, so that's going to be 24t minus 64. And again, we're just going to be substituting in a value of 5 in for time. And so then if I go to my calculator, I can do 25 times 5, and then minus 64, and that gets me a value of 56 for my acceleration. And again, don't worry about units with these. And then at the end, when does the particle change direction? So whenever the particle is changing direction, the velocity has to be at equal to 0, the instantaneous or instant velocity. Because in that instant, when you cut, like to go back from left to right, like the particle is doing, it needs to stop to turn around. And so that's why I know that my velocity is going to be at 0 at that point. So it's taking that derivative, so 12t squared minus 64t, and setting that equal to 0. Then you can either solve by factoring, or you can solve by quadratic formula, or there's many ways you can solve. I'd solve by factoring, so if I factor out a 4t, I'm left with 3t minus 16. And now there's something called the zero product property, which says if these are being multiplied together and they're equal to 0, that means each individual one can be set equal to 0. So for the look at the first one, if I had 4t equals 0 and I were solving for t, you just divide both sides by 4 and you would get t equals 0. So that's one answer. The other answer would be taking that 3t minus 16 and setting it equal to 0 and solving. So I would add 16 to both sides, and I get 3t equals 16. Divide both sides by 3, and you get another time of 16 thirds, or 5.3 repeating seconds. And that's the answer we care about, because at t equals 0, like that's when we're starting to watch what the particle is doing, so that doesn't really matter too much. So I hope you found this video helpful, and have a great day.